Greetings and welcome, friends. Mr. Wadi here. We're taking a look at page 178. We were talking about transformations, more specifically translations, and within that concept, we considered the idea of vectors. A vector was something that had both direction and magnitude. So it was kind of which direction am I going and how far am I traveling. Vectors are very helpful things in the world of modeling scientific concepts such as force, right? Things like that. But here we go. Let's talk about name the vector and write its component form. So this vector would have been vector CD. It almost looks like a ray according to its symbol, but it's like a little harpoon, I believe, is the typeface name for that symbol or whatever. So to name this vector in component form, we actually think about it in terms of horizontal and vertical movement. So horizontally, to go from this point to this point, it goes over. I just realized I'm like green on green here. That's okay. All right. So horizontally, it's moving over 1, 2, 3, 4, 5, 6, 7. So it's over 7, and it appears as though it was going down how many units? Down 3. The way we describe down would be with a -3. So vector CD. Excuse me, gentlemen. Vector CD written in component form would have been 7, -3. Okay, so down 3 over 7, more specifically over 7 down 3 probably would have been the better way to think about that problem. So this is component form. The horizontal component is this horizontal vector. This vertical component, the vertical component is this vertical vector. And actually, one of the interesting things about vector addition, which you don't have to know right now, is if I add two vectors together, the moving from the beginning to the end is the resultant vector of those two vectors. Yes, question? That is the transformation translation, I believe, which I think we'll do some of those in a moment. Let's see. It says the vertices of triangle DEF are the following, and then translate them using the given vector. Okay, so here we go. Let me those are all positive. Okay, so I'm going to assume this is X and this is Y. Is it going to fit my other one though? Let's see, left 3, down 7. No, it isn't. So, okay, so I've got to, I'm going to do, did I give myself enough space? All right, here will be my y-axis, my sad y-axis. There's my x-axis. And I'll do roughly the same thing over here. I don't know. Yeah, it might not fit. That's okay. I'll do my best. So what I'm going to do is plot the original points, which that is called the pre-image, and after the translation takes place, I'm given the image, okay? Like after everything was moved around. So let's see, here's the pre-image coming at you, over 2, up 5, right there. Oh, classic Wadi mistake right there. Over 2, up 5. Isaiah, you put that away, please, my friend. Thank you. There's D. There's E is 6, 3, so over 6, up 3 is right there. And let's see, F is 4, 0, so over 4 right there. Yeah, you're definitely right. It's not going to fit. So here is F. So here's the triangle. If I was taking my time, I'd use my ruler tool. So I'm translating this by the vector 6, 0. Okay, so that means I'm going horizontally over 6 units. So let's see, 1, 2, 3, 4, 5, 6. I counted wrong. 3 and 3 is 6. So this is where D prime would be. D prime. E would move over 6 units. That would be right here. That's E prime. F would move over 6 units. 1, 2, 3. Oh, 1, 2, 3. There would be F prime. And so if I map just simply the endpoints of the object that I'm translating and then connect the dots, assuming I was able to do that successfully, my image would be congruent to the pre-image as well as all of its corresponding parts. So DE is congruent to D prime, E prime. The angle D is congruent to the angle D prime, etc. And that's how that would work out. Okay, so question. Line, yeah, good point. All of these corresponding segments, if I imagine those as lines, would be parallel to the original. Good point, yeah. Let's see, let's plot D again. Let's see, I should have just copied and pasted it. See, what was this? 6, 3, so over 6, 1, 2, 3, 1, 2, 3. Yeah, plotting points. Good old times, plotting points. So there's F, and let's see, for my image, this one would be backwards 3, so backwards 3, and down 7. So here's my new D prime, all right? So let's see, I'm going to run out of space, I know. Backwards 3 and down 7, there is E prime. And then let's see, backwards 3 and down 7, there is F prime, something like, right? And so all of these points are going to be translated, and the image will be congruent to the pre-image as well as all of its corresponding parts. Good, good, good. All right, let's see. So write a rule for the translation, okay, of LMN, triangle LMN to triangle L prime, M prime, N prime. So now check this out. If I'm looking at this vector here, M being mapped onto M prime is something like that. But I want to think about it in terms of its kind of component form almost. So it's going left. How many units? Looks like 3, 4, 5. So -5. And it's going up 2. All right. So if I asked for the component form of the vector, it would have been -5, 2. That is, however, not what we refer to as the rule for the translation. The rule for the translation would be how do I map a point to another point from the image to the pre-image? Question? Oh, so what's that going to be? Yeah. And y plus 2, yeah. So you take whatever your original x coordinate was, subtract 5 from it, whatever your original y coordinate was, add 2 to it. So this is what we refer to as the rule for the translation. All right? All right, good, good. Let's see, last question. What are we doing for time? Yikes, man. Yeah, this time is flying by. Let's see, triangle PQR with vertices, blah, 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 and its image after the translation. Okay, so same idea. Let's plot these points and let's translate. It's going down 5. I'm definitely going to need to give myself some space. Let's see, I think this will be enough. So if this is my x-axis like that, and my y-axis looks like 2, 1, 3, and I'm shifting. Yeah, so this should be able to land somewhere in the middle. So there's my pretend y-axis. Let's plot our pre-image, if you will. So P is -2, 3. So something like, there's P. Q is 1, 2, over 1, up 2. There's Q. And R is 3, -1, R. Okay. So if I want to use this rule for translation, all of my x coordinates will be subtracted by 2, and then the y coordinates are subtracted by 5. So this point, which actually notice I could do this without graphing it, theoretically. I could have just said P prime is going to be the point, -2 minus 2 would be -4, and 3 minus 5 is going to be -2. Let's see if that actually makes sense. So left 2 and down 5, it worked out. So if I wanted to avoid a graph, which I always want to, and they didn't ask me to graph it, I could have used the rule for translation and just simply applied them to those coordinates and just kind of visualized what was happening. So let's see, to go from Q, so left 2 down 5 right there. There's my Q prime. And then let's see, for R, left 2 down Yeah, cinco, r prime. And notice I'll do one more of these. R prime, if I did 3, negative 1, 3 minus 2 would have been 1, and negative 1 minus 5 would have been negative 6. And is that, in fact, where I landed? Over 1, down 6. Cha-ching. It worked out. So there you go, friends. Thanks for watching. Have a great day.